All right, folks, how we doing today? I got probability distributions. We want to figure out what a discrete random variable is. We want to figure out the properties of discrete random variables, and we want to construct a probability distribution table. So let's get started. All right, first start off by copying these things down. Just go ahead and pause this and copy it down. I'll talk about them real quick. All right, so I hope you did that. And if we take a look at this discrete random variable, all right, it's quantity whose value depends on chance, an outcome of a random event. So we're going to throw dice, spin a wheel, pull a card, something like that. Now, this just means the probability of my discrete random variable x, when it's equal to 3, well, the probability is going to be equal to 1/6. And then this just means that when I've got the probability of my discrete random variable x, and it equals x, that means it could take any given number or there's several numbers. And then make sure you're clear that the capital X stands for the variable itself, and then the small x stands for the different values that could take its place. So, discrete random variables, they come from probability. For example, if I threw 2 dice, maybe I would say that x is the sum of the face-up sides. Or maybe I would say y is equal to the product of the 2 face-up sides. Or maybe I would say z is the larger of the 2 dice. Now, discrete random variables. The probability distribution of a discrete random variable is simply a listing of all the possible values of the variable and the corresponding probabilities. So, for example, think for a second about throwing a dice. What are the possibilities as far as throwing a dice? Well, we could get a 1, a 2, a 3, a 4, a 5, or a 6. And then what are the probabilities of each one of those things happening? Well, each one of them has got a probability of 1/6. So if I'm going to make a probability distribution table, it's going to look like this. All right, I've got x, and there's my possible values of 1, 2, 3, 4, 5, and 6. And then right below them are going to be their probabilities. And again, this is the probability of the variables for each given x. And then you'll notice that when you add all these up, that equals 1. So here's a little example. If I take 2 dice and throw them, this table shows all the different possibilities if I add up the sum of the 2 dice. For example, if I were to throw for example, if I were to throw a 1, for example, if I were to throw a 1 and a 1, the sum of those two would be a 2. If I threw a 6 and a 6, the sum of those two would be a 12. So the whole table, if you go across and over, if I throw a 3 and a 2, it's going to equal 5. These are all the different sums of throwing 2 dice. What I want you to do is see if you can't figure out how to make a probability distribution table for this information. Now, the first thing you got to figure out is, what are the possible outcomes? What's the smallest outcome? Smallest outcome is a 2. What's the biggest outcome? The biggest outcome is a 6. So across the top of your table, you're going to have the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, because those are all possibilities when I throw 2 dice. And then below each one of those is the probability for each one. So, for example, there are 36 different possibilities. How many 2s are there? So the probability of getting a 2 out of throwing 2 dice is 1/36. Why don't you try doing that for all the different values? Pause it and give it a try. All right, hopefully you got something that looks like this. And if you did, you probably notice that when you add up all the values, you'll get a total of 1 for the probability. Now, we also can take a probability distribution and we can make a bar chart out of it so we can get a kind of visual of what happens. I mean, you can kind of get it here when you're looking at the table, but when you look at the graph, it's really clear that the 7 is got the highest probability when you throw 2 dice. All right, look at example 2. It says the bags contain 2 red and 3 blue marbles. 2 marbles are selected at random without replacement. The number x, now that's our discrete random variable, of blue marbles is counted. Find the probability distribution of x. All right, so first start by making a probability tree for this situation. What we're doing is we're pulling out 2 marbles and draw a tree. I'll pause, wait. All right, hopefully you did that, and hopefully you got something like this. And this is getting 1 red the first time and then getting the second red. This is getting 1 red the first time and then a blue the second time. So anyway, we multiply the probabilities straight across, and then we can find the probabilities for each one. And also I want you to consider what our x's are. The x's are the number of blue marbles. So in this first outcome, how many blue marbles did we get? 0. In the second outcome, how many blue marbles did we get? 1. In the third outcome, how many blue marbles did we get? 1. And then in this one, we got 2. So first thing I want to make sure we're clear about is there's a lot of stuff here, but the only thing I'm really interested in is the number of blue marbles, because that's my variable, my discrete random variable, and that's what I'm finding probabilities for. So what are the possible numbers of blue marbles that could be pulled out of this bag? Well, I could get 0, I could get 1, or I could get 2. So make a probability table like we talked about, where the different possibilities are across the top. You got 0, 1, and 2, and then find the probability of each one, and then put that below. Pause it and try that. All right, so hopefully you got these as your probabilities, and then hopefully when you put them together on a table, you got something like this: 1/10 and 3/5, 3/10, and then it should equal 1. Now, another important probability or property of probability distributions, and we've already made it clear, is that when you add up all the probabilities, it's going to equal 1. And that's all this notation says. If I add up all the probabilities of the discrete variables of the same group, they should equal 1. So that can be helpful as far as answering this question. Remember, these down here are the probabilities. So I'm telling you, if this is a probability distribution, those all should add up to the number 1. So can you figure out what C's got to be? Try to do that. Pause it. Try it. All right, hopefully you did that and you found out that if you add up all that stuff and it equals 1 and you combine your C's, you'll find out that C should be 1/8. Now, it asks you to find the probability that T is less than or equal to 3. Well, that means this probability plus this probability plus this probability. So that's all this is asking. And now I know what C is. You should be able to figure it out. Pause it and figure that out. Right? Hopefully you got 5/8. And then for C, the probability of T being greater than 3, well, that's going to be these two probabilities added together. And again, if you know what C is, it shouldn't be that big of a deal. Try it. Okay, hopefully you got that. That's 3/8. Now, in example number 4, a computer is programmed to give single digits, and that variable we're looking at we're calling it x, and the digits are going to be 0 and 9 inclusive. So that means it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, it's going to be set up in such a way that the probability of getting an odd number, 1, 3, 5, 7, and 9, is half the probability of getting an even number, 0, 2, 4, 6, and 8. So now, how can we use that information to figure out the probability? Well, start by trying this. Let the probability of getting an even digit be C. And if that's true, well, then we must know that getting an odd digit must be 1C. So, what happens when you add up all these probabilities? If you add them all up, you should get a 1. So if you add up all the C's, and 1/2 C's, you should find out that 15 over 2 C is equal to 1. Well, if I do 1 divided by 15 over 2, that's the same thing as 2 over 15. C is equal to 2 over 15. So now remember, C is the probability of getting an even digit. So now, what's the probability of getting an odd digit? Half of C, which half of 2/15 is going to be 1/15. All right. Now take a look at number 5. A bag contains 4 red and 5 yellow balls. 5 marbles are selected at random without replacement. The number of red balls taken is X. So in this case, X is the number of red balls that are pulled out of the bag. Find the probability distribution. So pause it and give that a try. Alright, so if you're a little bit stuck here, try this. Use combinations to figure out the number of ways to choose 5 balls. How many different ways can I pull out 5 of the marbles? Because in this case, it doesn't make a difference what order I pull them out in. So how many balls do we have altogether? We've got 9 balls. And so if I want to know the number of ways I can pull out 5, that's going to be 126. Now, I can use combinations to figure out all the different variations that I'm interested in. For example, one would be if I got 0 red balls and 5 yellow. So that would be 4 combination 0 times 5 combination 5, and 4 combination 0 is 1, and 5 combination 5 is 1. So that's going to be 1, and so that means that there's only one way that can happen, or one way to choose those. And so the probability of getting 0 red balls is going to be 1 out of 126. And then what you can do is you can repeat that process for all the different possibilities. Well, so now what if I got a red? Well, now this is going to be 4C1, and this is going to be 5C2 or 5C4. And then what about if you get 2 red? Well, now it's going to be 4C2, and it's going to be 5C3, and so on. So figure out all the different ways and divide each one of those by 126, and those are your probabilities. And then see if you can make a probability distribution chart. I'll pause it and we'll wait. All right, hopefully you did something like this, and you didn't have to write this part, but this is where the numbers are coming from. Remember, we've got the possibility of getting 0, 1, 2, 3, or 4 of the red balls, and so when I do that, these are the different combinations that could come out, and all I got to do is multiply them together and divide by the total. And then when I get my table, it should look something like this. I'm talking about X could be 0, 1, 2, 3, or 4, and then these are the probability for each one of those things happening. So you can see how using the combinations would be helpful in this particular problem. All right, a probability distribution is a model. Now, for example, if I throw a dice, you would expect that 1/6 of the time I would get a 1, and 1/6 of the time I would get a 2, and 1/6 of the time I would get a 3, and 1/6 of the time I would get a 4, and 1/6 5, and 1/6 I would get a 6. So you would expect that if I threw the dice 360 times, that I would get about 61s. I would get about 62s. I would get about 63s, and so on. Now, it's really unlikely that they would all come out to be exactly 60. It is true that the more numbers, the more times I repeated this, they should get closer and closer to 60. But it should be, not too crazy. So, for example, what conclusion would you draw if you did this 360 times and there was like 10 ones instead of 60? Well, that probably would indicate that maybe your dice isn't a fair dice. Maybe it's lopsided, or it's not, perfectly cubical or something. Now, we also can take this kind of information and we can figure out stuff with the frequency divided by the total frequency is the probability. Well, if I multiply total frequency on both sides, I can find that the frequency is equal to the total frequency times its probability, which is what we just did. In this case, we found the frequency of 60 by multiplying 360 times 1/6. So another example would be is if I choose a card from a deck of a random card from a deck of cards that's got 52 cards in it, and I did it 520 times. How many times would you expect to get a king? Well, first, what's the probability of getting a king? There's 52 cards, so there's 4 kings. So the probability of getting a king would be 4 out of 52. If I take 4 out of 52 and multiply that by 520, then I should get about 40 times I would expect that I would get a king. And that's how that works. Thanks for watching, and I hope that helped a little bit.